I'm John Scripter. I'm going to talk about vapor phase remediation, SVE and air sparge. SVE, soil vapor extraction, and air sparge. So we've got a unit up here I'll be modeling and showing here in a second. I just want to go through and talk about what is SVE, what is air sparge, and go through those details, and then we'll talk about one of the systems. This screen here is just showing the the contamination problem and what's being done to restore. So you've got a leaking underground tank that's impacting the soil. You've got a product layer here that's also impacting the groundwater. Earlier we talked about product recovery systems, water treatment systems. Now we're going to focus on the vapor phase, which is basically cleaning the soil. So with the soil contaminated, it can get into someone's basement, the fumes, and so we use blower systems with this section of piping to basically draw a vacuum in the soil and transfer the contaminants from the soil into the blower and the discharge and out to a treatment system. So what is soil vapor extraction? It extracts contaminants from the subsurface in vapor form, and so they're designed to remove contaminants that tend to volatilize, like gasoline, some diesel, and we can also do some chlorinated. Like I mentioned, we apply a vacuum through a series of underground wells, and the contaminants are pulled as vapors to the surface. Typical SVE system, little diagram here shows the blower connected to the wells that are in the subsurface, and shows the effluent going through carbon vessels. So you would treat the vapor phase either with carbon or with an oxidizer, a thermal, or an electric catalytic device. And so it works.
So you can have these systems in a bioremediation type of setup as well.
Yes. So it won't remove heavy oils like PCBs or dioxins, but it's generally for VOCs, volatile organic compounds, like gasoline, diesel. So the applicability, it's targeting those VOCs that I just mentioned with a Henry's law constant greater than 0.01. And I'm not a chemist, so I won't go any further than that. But other factors such as moisture content, the permeability of the soil, is it clay or is it sand, will affect how effective the SVE system is. And because it's a continuous flow of air, it promotes in situ biodegradation or bioremediation of compounds.
Yeah, like a giant plumeter almost.
Correct. Limitations. As mentioned, soil that has a high percentage of fines or high degree of saturation will require higher vacuums, larger size blowers
For suction.
for suction. Large screen intervals are required in extraction wells for soils that are more tight.
So what is that called? Sorry to interrupt. What is that called, John? So like in water, when you want to get a viscosity test to kind of find out what meshes to use, what is that test called to find out how?
Well, you would need to do a pilot test. Basically, you would either rent a blower or and do a test on a well to see what your radius of influence would be.
If it needs to be increased or decreased or what?
Increase or decrease, and you can determine what CFM and what vacuum you need to treat that area of radius of influence that you need to treat.
Gotcha.
So soil that has a high organic content or extremely dry has a high absorption rate, and it will reduce your recovery, removal rates. It's not affected in the saturation zone, so you can't use it in the water. That's what the air storage system that we'll be talking about is for. The exhaust air from the SVE may require treatment depending on where you're located. And when you're drawing a vacuum, on air, you're going to create moisture. And that's what you see the blue tank on that skid there, that's a moisture knockout drum.
Was it just filled with desiccant or something to that?
No, it's basically just an empty drum. It's for the moisture in the air to drop off.
Oh, okay, sure.
And once that drum is full, you may need to treat the water because that water is contaminated.
Through carbon as well?
Yes. So what we need for sizing a system like this is the contamination, your concentration of the contaminants, your depth to the water table, your soil type. And so all of those are taken into consideration when you're doing a pilot study to tell us what you need for CFM and for vacuum, and we size the blower based on that information.
Is one of those sheets available on, like for like a site, like if you're doing to find out, how many wells and all that kind of stuff? It's one of those sheets that has all the pre-stuff filled out? Like in other words, if I'm talking to a client that would want to speak with you, I'd want them to fill that out first. Do you know what I'm talking about?
Yeah.
Okay.
Yeah. But when you're talking to a client, what you want to ask for, okay, what do you need for CFM? And at that CFM or flow rate, what do you need for vacuum?
Okay.
And what is your contaminant? Do you need a system to be explosion proof?
Oh, yeah, that's another.
So additional needs, electrical power, what do you have for available power, what your classifications are. Are you at a gas station? Are you remediating gasoline vapors, or are you at a dry cleaner? Gasoline requires explosion proof. Dry cleaner is basically chlorinated solids that you can get by with a less expensive non-XP blower. What are your sensors or gauges that you require for the system? Are you looking for a system that's skid mounted? Are you looking for something that's installed in a trailer, in an enclosure? And what kind of devices do you need? Transfer pumps, heat exchangers, that kind of thing. First thing you need to establish is CFM. What are you measuring? There's different synonyms for CFM. SCFM, ACFM, and ICFM. What does that mean? SCFM, definition of SCFM is standard cubic feet per minute. And that's based on a standard set of data. Basically, 14.7 PSI, which is sea level, 68 degrees Fahrenheit, and 0% relative humidity. Those are perfect conditions that you would use for the term SCFM. FM stands for actual cubic feet per minute. That's typically what we use in sizing the system. What do you actually need for CFM? For instance, a blower that's doing 50 CFM at 50 inches of water in New England at sea level will not do that will not do it at elevation in Denver. You have roughly a 15 to 20% reduction in the blower efficiency based on elevation. So we would have to upsize the blower to get that 50 CFM at 50 inches of vacuum. ICFM is inlet cubic feet per minute. That's what you need at the inlet of the blower, or inlet of the skid, I should say. Gauges, the majority of the gauges that are available commercially are they show their an SCFM, but are you really at those conditions? We're not at those conditions here because we're not at sea level. You have to be at 68 degrees Fahrenheit with 0% relative humidity. So how often are you actually at those conditions to be able to say, I need SCFM? Fictitious. Yes. And so this chart just shows the difference in barometric pressure versus altitude. The 14.7 PSI is at sea level, and then Denver 5,000 feet, that same blower is 12 PSI because of the elevation. And so the equipment options we have several different blower options depending on what you need for vacuum and flow. They include fans, a regenerative blower, which is on this skid here, a rotary lobe or rotary vane, and a rotary claw. Again, we would design a system based on what you need for vacuum, what you need for flow, and then size and design that blower based on that application. We can provide them on a skid, much like you see here, a trailer mounted or inside of an enclosure. Complete systems include knockout drums, a transfer pump, different gauges and switches and controls. So what I want to show you here is turn the camera around. Is a typical regenerative SVE skid. This is what we have in our rental fleet. This is a 1.5 horsepower unit here. It's explosion proof. We rent these out for pilot studies or short-term.
Is it a 1.5 horsepower pump, but a 5 horsepower blower?
No, it's a 1.5 horsepower blower. You've got the control box here that's explosion proof.
Gotcha.
This system comes with a couple of different alarms. You got a high vacuum alarm, so if the line gets clogged with anything, it will shut down. That way you don't overheat the blower. There's also a high level switch into the drum. So as the drum fills up, we don't want it to overfill and start sucking water into the blower. So we shut the system down then, and there's a manual drain here on the side. This particular configuration, we build up to 10 horsepower with a regenerative blower. Once we get above that and a different type of blower, we'll have to use different materials, different, if this is using a like standard 55-gallon drum, we'll use a stainless steel drum for higher vacuum applications. Otherwise, it would crush the drum because this is under a vacuum.
Sure. That's cool.
The skid is roughly a 4-foot square. We have different sizes. We have enclosures we can put these in, and on trailers as well.
How much would something like that go for rental?
We rent this particular system from 1.5 up to 10 horsepower for $1,600 a month.
Wow.
And we also rent it weekly. I believe it's like $600 a week, something like that. So rule of thumb, CFM and vacuum ranges based on different blower types. You can see in the chart there. The most common is the regenerative that we supply, but we've also done a lot of the rotary lobe, which are basically positive displacement blowers, and the rotary claws. And just a couple of pictures here of different applications.
Centrifugal is more for higher flow?
Higher flow rate. Yeah, high flow rate, but a lower vacuum range.
Gotcha.
And this is a centrifugal blower here. They're using a stainless steel knockout tank because they need a higher volume than the standard drum would provide. Regenerative SVE, that's this skid here, put inside of a hazmat enclosure. Again, another picture of that. This particular unit here has a transfer pump to automatically empty that knockout drum. And then we have a controller mounted on the outside that operates the system.
Big pump.
Yeah. That's the skid you see here. Another positive displacement, that's a rotary lobe application. It's using like a belt-driven pump.
Yeah, I see that.
And those are for a higher flow, a little bit higher vacuum applications.
A lot more dedicated too, it seems.
Yeah. Rotary vane is a lower flow rate, but a higher vacuum application. And you can, you see the stainless steel knockout tank there. And rotary claw, same thing. Rotary claw would give you a higher flow rate with a higher vacuum. So those are the solid vapor extraction, air sparging. So since SVE can't remove contaminants from the saturated zone, we use an air sparging that actually pushes air into the contaminated water to bubble the water release the contaminants into the soil, where the SVE will gather them and run them to the treatment system.
That's cool.
It's like an in-well
So
air
it's like
system.
essentially the same system, just with percolation in it.
It's percolating the water to release the contaminants from the water into the soil.
That's cool.
So with an air sparge, if you have three-phase product floating on top of the water, you really can't use that application. It has to be just contaminated water only. It has to, you have to have all the product recovered from the water table to be able to use an air sparge.
Makes sense.
So for that to be successful, the soil in the saturated zone must be loose enough to allow the injected air to allow the contaminants to escape into the unsaturated zone.
And so that'd be part of like their pilot when they go out to look at that clay or look at how porous, I guess it is, to
Yes.
see if that would work.
Yes. So before you size an air sparge blower, we recommend doing a pilot test. Again, like with the SVE, you will rent a blower and you'll determine, okay, how much air do I need and at what pressure do I need to overcome getting the contaminants into the soil for the SVE. And also a rule of thumb, when you're sizing an air sparge and SVE system, the air sparge airflow wants to be 1/3 to 1/5 of the flow lower than the SVE system. You don't want to run a sparge system without having an SVE there because you're pushing contaminants into the soil, but you need to have the SVE that can collect those
At the same rate.
and bring it to the surface. So the SVE is always going to be at a higher flow rate than the air sparge will be. And the reason for that is if you're running an air sparge without the SVE, you have the chances of moving the contamination off site and spreading the contamination in the soil.
So you'd actually make it worse if you're not sucking it enough.
Correct. As with the SVE, we have several blower options available, again, depending on your flow rate and pressure requirements. And again, as with the SVE, we can mount these on skids, put them in an enclosure on a trailer, and we set them up with controls so they work in conjunction with an SVE. If the SVE system shuts down on any of those two alarms that I showed you, the air sparge would be shut down. You can run the SVE without the air sparge, but you can't do
Vice
reverse.
versa. Yeah.
And just a rule of thumb here, different blower types with their CFM and pressure ranges that we have available. So regenerative would basically be a very low pressure range, all the way up to a rotary screw, which has a very high pressure range. The rotary claw and the rotary vane are probably the most common used that we've found in systems that we've supplied. But the rotary lobe or the positive displacement have a lot of applications as well. Regenerative, it's basically that same blower. Instead of using the vacuum side into the ground, we're actually reversing it and using the pressure side for the air sparge. This is the positive displacement or the rotary lobe, belt driven, comes with its own silencer and filter. And again, it's sized based on pressure and flow rate that you need. Rotary vane, this just shows a rotary vane with basically a manifold set up for the different wells that they're pushing the air to. Rotary claw application, that's one of the most common for the air sparge that we've done. Again, using the blower and then the piping would be connected to, because these systems are connected to a series of manifolds, depending on how many wells that you're either drawing a vacuum from, or in the case of an air sparge that you're pushing air into. And the rotary screw. This is like a continuous duty compressor, but has applications in air sparge applications as well. And this is just the control panel, we call it a GECA control panel that we would use for operating both blower systems. It's NEMA 4, weatherproof, you would put the controller in a non-classified area and just run electrical out to where the blowers are, depending on what your application is. If you need to be explosion proof, the controls have to be in a non-classified area. So in summary, we need the proper data to choose the right blower for you for your application. Any questions?
Essentially, majority of the system is explosion proof other than the extra PVC pipes, is that correct?
Correct. In this example up here,
Yeah.
yes, the control panel. What makes the control panel explosion proof is it's got the machine surface from the lid to the base. And every time that there's a switch closure, there's a spark. And it creates gases. And by the time those gases escape across that machine surface between the two, the lid and the base, they're cooled off enough so that they don't cause an explosion outside the box. Same thing with the motor that's on that blower. Every time their motor turns on, there's sparking going on in there. But the gases are cooled off enough so that it doesn't cause an explosion at your site.
Okay.
Where other types of blowers that don't have those explosion-proof enclosures would not have that
Awesome.
capability.
How loud are they when they're running these systems?
They can be quite loud. That we have mufflers available because most of the noise that you're going to hear from a blower such as a regenerative is coming from the exhaust. They can be like a high-pitched whine, but if you put a muffler on the discharge side of the blower itself, it quiets it down. We had an application in Brooklyn, New York, where they were building like a new like a small mini mall, and they had two of those blowers in the basement, or actually, I'm sorry, two of those blowers on the roof, and they would run the piping down through the building into the basement where the knockout drum was, but they put blowers on all the piping, and you couldn't hear them.
On the setup where it had a filter, what is it filtering? Just the exhaust?
No, it's filtering the inlet.
Oh, okay.
So for any
Just cleaner, drier air?
correct, if if there's silt or any kind of fines in the airstream,
Especially maybe a humid location or something?
right, it's more for fines and solids.
I imagine those belt-driven ones are even louder.
Yeah, but they come with, as you saw in the picture, it comes with a large muffler to quiet it down.
Pretty cool job, thank you, sir.
Any other questions?
Is there a sample port on there?
Um,
For, the IDs paper?
yeah, on this particular one, there isn't, but it's easy enough to put one on.
Is there?
Yeah. And it's whether you want it on the influent piping going to the blower itself or attached to the wells. All right, thank you, everyone.
Thank you.